Okay, so for problem 429, we are going to be looking at the figure that you see here. We have a 12-foot wooden beam weighing 80 pounds. So you'll notice that they put that 80 pounds at the geometric center of this beam. So that's the 80 pounds going down. So the beam is 12 feet long, so 6 inches or 6 feet from either side. It's supported by a pin at A. And it has a cable from B to C. They want us to find the reaction at A and the tension in the cable. So first things first, we got to draw our free body diagram of what we see here. So you're going to add the 80-pound force going down where they show it. And then you're going to show the reactions at A and at B on this beam. So I'm going to draw mine in the background here. I'm going to let you draw yours, and then we'll compare. So as we look at our free body diagram here, our 80 pounds is our only known applied load, okay? The other forces that I have here are going to be the supports. So at A, we have a pin support, so we know there's two reactions, an X and a Y. At B, there is a cable going up to point C. So I called it capital T, B, C, just for the tension in cable BC. You could just call it tension. You could just call it TB, whatever. You could call it B, you could call it C, whatever you want to call it, but make sure it's consistent and labeled. It is going at an angle. The horizontal distance over to B from C is 8 feet, and then the vertical distance up to where C is 6 feet. So I have this angle alpha identified here. We'll be calculating that so that we then can get our X and Y components in terms of the hypotenuse, okay? And that's really all the information that we need on our free body diagram to proceed. Any questions at all? Where did I get the 2 feet? Oh, sure. Let's look. So you'll notice here that I had 6 to the 80, and then this was 8 feet back. So that means it's 2 is the difference right here. Yep. Good question. Thank you. Any other questions? Okay. All right. So next step. What do you think? Components. Yes, Nicholas says components. So go ahead and calculate your components with your X and Y in terms of their hypotenuse or the tension in that cable. So at this point, you should get your X component of 0.8 times the tension in BC. So again, the X component in terms of its hypotenuse, and then the Y component should be 0.6 times the tension in BC. Once you have those components, I'm going to pick a virtual. Tell me, Gabrielle, tell me, what's our next step, do you think? Equations of equilibrium. You got it. Yes. Equations. I'm going to abbreviate equilibrium. Absolutely. So we've got our 3 equations of equilibrium. We will be able to solve for. You're solving for the tension in BC. Okay, so if you are going to use the X and the Y components here of that tension, make sure you put in terms of the hypotenuse. Otherwise, there'll be too many unknowns, right? And then you have your AX and your AY to solve for. And I am confident that you can take it from here with a good setup. Any questions on what we have for this one? Okay, if not, then let's turn the page and look at our last problem for Module 5. Oh, this is a good one too. We actually had done problem 436 in our practice problems. So if you want to look back, that would have been the very last problem that we did. And then we are assigned for our application problems number 37. And this time it's really everything is the same except beta is 60 degrees this time. Last time it was 30. Okay, so we're going to use 60 degrees here. So go ahead and draw the free body diagram for this illustration. I'm going to draw mine on the side. I'll leave this up. Should have been doing that before. But see what you come up with for problem 437. And you can look back at your practice problems. I mean, one of the reasons we do these, and we do have, I think there's about 3 of them that kind of use the practice problems as a, did it one version and then we have another version. A, B, and then C. What kind of a reaction do we have at D? Or I should say, what kind of a support and how many reactions would we have at D? Tim, what do you think? Two. Why? What type is that? What would we call that? That's okay. It's a pin, exactly. Yep, pin reaction or a pin support. We have two reactions, one in the X, one in the Y. Excellent. What about at A? Let me go back to virtuals. Let's see who hasn't gotten a chance yet. Alexander, what are you thinking? What type of a reaction or what type of a support is A?
Is it a roller?
It's a roller, exactly. A roller is always going to have one reaction. It's going to be perpendicular to the surface that it's riding on. So since this surface is vertical, our reaction at A is going to be horizontal. So show you my free body diagram. Mine looks like this. Does yours look kind of, oh, I'm forgetting something very critical. I thought I was done. What did I forget?
The lamps.
All the distances, right? Yes, all the distances. I'll add those really quickly here. So 180 millimeters, 100 millimeters, and 280 millimeters. Okay. All right. So there's our free body diagram. What is our next step then? After we have a good free body diagram in place with all the dimensions as well as all of the appropriate forces, my step number 2 on this one will be, Drew, what are you thinking? Components, exactly. Yes. We have a CX and CY to calculate the components for. They gave us the 60 degrees from vertical. So be careful. It is not in that standard position, if you would, for cosine times the angle. This would be for the X component, it would be the sine. And for the Y, it would be the cosine. I'm going to let you do those. After you have your components in place, what's our step number 3? I think I did everybody virtually. Everybody got a chance. Camden, did you get a chance to talk today? Did you talk today? What are you thinking? What are you thinking for our next step? For number 3, after we get our components done, what is going to be the next thing that we're going to do? Yep, equations of equilibrium. Excellent. Yes. You guys are like, this is like easy, Kelly. We don't need you anymore. We are statics experts. And the whole reason that I try to kind of do this for you guys so that you see that there are 3 steps essentially, but 1 or 2 or 3 steps. We always start with a good free body diagram. Then we kind of look at where we're at. We may or may not have to do components. It just depends if there's anything at an angle, right? If we see any forces at an angle that aren't in there, that aren't already in the X or the Y direction, then we've got to do components. But then we end with those 3 equations of equilibrium. There's really 2 to 3 steps for each one of these problems. So yeah, any questions on number 37 to finish this one up? Okay. All right. So that really concludes kind of going through and making sure we've got good setups and or working through the application problems that we have here for module number 5. So I'm going to stop the recording here.